In this video, we talk about VLAN concepts. Let's get started with the question, why VLAN? To answer the question, let's look into this network diagram. It is a typical network in the real world where the clients are scattered around multiple buildings and they are connected to hundreds or even thousands of switches, and the servers are centralized at a data center. With the default switch configuration, the network contains two broadcast domains. This is one broadcast domain and this is another broadcast domain. Now, in my opinion, there are three main reasons why we need VLAN. Here is the first reason. As you know, most of the time the clients needs to access the resources from the server. In order to do that, they have to generate broadcast frames to find the MAC address of the default gateway. Broadcast frames must be processed by all the switches, which increases CPU overhead and reducing performance on each device in the network. Now let's look into the second reason. As a network engineer, you are usually asked to create a network access policy such as allow all the client's computer to access the web server and allow only two computers over here to access the file server. With single broadcast domain, there is no way to set network access policy for each group of computers. And the third reason is that when there's a layer 2 issue happens in the network, such as this computer send a malformed frame, the frame will be traveling freely among all the switches in the network. It is really hard to isolate the sources of layer 2 issues happen in the network. So these three main reasons create the need to reduce the size of the broadcast domain, which in turn creates the need to have virtual local network or VLAN. So what is VLAN? As you know, a switch can be configured with some interfaces into one broadcast domain and some into another, creating multiple broadcast domains. These individual broadcast domains created by the switch are called virtual LANs or VLANs. So in this network we have VLAN 10 and VLAN 20. The link that belongs to multiple broadcast domains is called chunk link. In this network we have this link is a chunk link. Let's now move on to another important concept, which is VLAN Touching. As you know, chunk link connects two switches together and allows frames from any allowed VLANs to flow from one switch to another. To identify the VLAN of a frame, switch tags the VLAN information when the frame comes into the chunk and remove the tag when the frame goes out of the chunk. Let's look into the network diagram. We have VLAN 10 and VLAN 20. Let's say PC2 wants to send the frame to PC6. It must forward the frame to switch A. Switch A knows the frame belongs to VLAN 10 and it must forward the frame across the chunk. It checks the VLAN allowed list of the chunk and knows VLAN 10 is allowed. It tags the VLAN 10 information to the frame and forward it to switch B across the chunk. When switch B receives the frame out of the chunk, it reads the tag and knows the frame belongs to VLAN 10. It then removes the tag and forwards the frame to PC6. Similarly, when PC4 needs to send frame to PC8, it must forward the frame to switch A. Switch A knows the frame belongs to VLAN 20 and it must forward the frame across the chunk. It then checks the VLAN allows list of the chunk and knows VLAN 20 is allowed. It tags VLAN 20 information to the frame, then forwards it to switch B across the chunk. When switch B receives the frame out of the chunk, it reads the tags and knows the frame belongs to VLAN 20. It removes the tags and forwards the frame to PC8. Let's move on to the last two concepts, native VLAN and default VLAN. Native VLAN refers to a VLAN into which frame is untagged when it is received on a chunk port. Both switches connected by a chunk link must agree on the native VLAN. Default VLAN refers to a VLAN to which all ports are assigned when they're not being used. By default, VLAN 1 is the default native VLAN in Cisco switch. Let's now look into the network diagram and assume we make VLAN 10 is the native VLAN on both switch A and switch B. And PC1 needs to send frame to PC7 and it must forward the frame to switch A. Switch A knows the frame belongs to VLAN 10 and it must forward the frame across the chunk. It then checks the chunk for the VLAN allows list and knows VLAN 10 is allowed. It then figures out that VLAN 10 is a native VLAN, so it forwards the frame to switch B across the chunk without touching. When switch B receives the frame out of the chunk, it sees the frame does not come with a tag, so it knows the frame belongs to the native VLAN, which is VLAN 10. It then forwards the frame to PC7.